Okay, so today we have a number theory and algebra problem. I wouldn't really group it with the normal number theory problems because as you see, one, this is a high school level, a lot easier than a university problem. It doesn't use Fermat's theorem or Euler's theorem or any of that. Second, it's on it compared to normal high school math homework it's a little bit harder, I would say. But for competition math, I find it on the easy to intermediate sort of pile. So yeah, let's begin. So let n be a positive integer. What's the maximum value of n that makes n squared plus 2009n a square number? Okay, so pause the video if you'd like to figure out the solution on your own. I'm going to provide two different methods. One is more intuitive. The other one is more, algebra. And the second one's faster, but both methods follow a rigorous proof process. So first one, n squared plus 2009n basically is n plus 2009 times n. And if you agree with that, let's set an arbitrary number a and says this is a square number, so this equals a squared. And having that, we have two cases. Either n plus 2009 is the square of a number and n is another square number. We'll use p and q to denote that. So n plus 2009 equals q squared. Just not to confuse 9 with the q, let me just mark that. Okay, n plus 2009 is q squared and n is p squared. What does that mean? That basically means that n plus 2009, that times n equals p squared q squared equals pq squared. Excuse me, that was my alarm. Yeah, it's one of the system alarms, so I didn't record it. So okay, the other case that we have is n plus k times n plus k. So these are the only cases that I have, because it's impossible to, for example, that square number, a, it's impossible for that range of a to be outside of n plus 2009 and n because let's say if it is right here, all right, that's a. If that's a, then a squared is bigger than n plus 2009 squared, and it's bigger than n times n plus 2009. And having this inequality, we conclude that a is not anywhere on this side of the number lines. And if it's smaller than n, let's say a is right here, then a squared smaller than n squared smaller than n times n plus 2009. So a is definitely not here. So a must be somewhere in the middle within this area. So n plus k, that's a, because that equals a squared, right? So n plus k, that's a, this is another a. N plus k should be n plus k somewhere around here, where this is the value of k. So this number, square itself, equals n times n plus 2009. Let me just move this aside. And those are the only two cases. So, or rather, the first case is actually a more special case of the second. But yeah, n plus k times n plus k equals a squared, and that equals n plus 2009. Okay, so let's first look at case 1. Case 1, it would be the gap between two square numbers is 2009, because p squared equals n, q squared equals 2009 plus n, so q squared minus p, what am I doing? Oh gosh. Q squared minus p squared equals 2009. And of course, when you see that, you're going to think algebra, okay, q plus p times q minus p, that equals 2009. And immediately you see that 2009 is a prime number, so is q plus p, q minus p, it would only be one solution. This is 2009 and this is 1. And through that you get q plus p equals 2009, q minus p equals 1. And if you add both of these equations together, 2q plus p minus p just cancel out, equals 2010. Getting that q equals to 1000 and 1000.